Now we pass on to the problems from exercise 2.1. Simplify the following. Problem number 1, I power 1947 plus I to the power 1950. So we have learned how to simplify I power any higher powers of I. So let's first try to simplify I power 1947. Then we will simplify I power 1950 and we will add. So I power 1947, what did we see? Any higher power, any number can be expressed as a multiple of 4 plus a remainder. Why do we express it as a multiple of 4? Because we know that I power 4 is 1. Okay. So by division algorithm we learned, isn't it? So I power, now 1947 can be expressed as 1944 plus 3. And 1944 is divisible by 4. So I power 1944, which is a multiple of 4 into, actually I power 1944 plus 3. 1947 can be 1944 plus 3. And A power m plus n is equal to A power m into A power n. So we are splitting it as I power 1944 into I power 3. And 1944 is what? 4 into 486. If you multiply 486 by 4, you will get 1944 into IQ. And it is I power 4n. So you know I power 4n is 1. So directly also here we can put 1. You know that 1944 is a multiple of 4. So directly also you can put 1. Or you can express it and show that step. 4 into 486. So 1 into I cube. And I cube is 1 into I cube is I cube, and I cube we know that the value of I cube is minus I. Okay, then 1950 for that, I power 1950. So how can you write that as? Express it as multiple of 4 plus the remainder. So 1948 plus 2, I power 1948 plus 2. Again, you can write A power m plus n as A power m into A power n. So A power 1948 into I power 2. And 1948 is nothing but 487 into 4. Again a multiple of 4. So I power 4n into I square. And I power 4n will be 1. And I square is minus 1. So 1 into minus 1. Or 1 into I square is I square. And I square value is minus 1. You know I square is minus 1. Okay. So we have separately found the values of I power 1947 and I power 1950. Now the value should be for I power 1947 plus I power 1950. So we add. So what is I power 1947? It is minus I. What is I power 1950? It is minus 1. So I substitute. So it is minus I minus 1. Which can be written as minus 1 minus I. Because you put the real number first. This is imaginary part. Minus I is I imaginary. So we write the real part first. So it is minus 1 minus I. Is that okay? Next problem, find or simplify I power 1948 minus I power minus 1869. So here we have I power a negative number, and we know to simplify even negative powers of I. So we will now try it. 1948 again is exactly divisible by 4. You know the last 2 digits 48 is divisible by 4. Therefore 1948 the whole number will be divisible by 4. Anyhow, if you can directly write I power multiple of 4 is 1, oh yes, you can find. Actually that's what you get here, I power 487 or 1 power 487 or it is 1. Directly also you can write, but according to the steps, it is I power 4 into 487 minus I power, now 1869 should be split as a multiple of 4 and then the remainder. So here it is negative. Minus 1869, so you can write this minus 1868 minus 1. Okay, so minus 1869 is split as minus 1868 minus 1. Now this is I power 4, the whole power, because A power m n is nothing but A power m, the whole power n. This is a law of indices that you know. So it is I power 4, the whole power 487 minus. Now again I am going to write this as a multiple of 4. So this I divided and shown you that the remainder is 1. 1869 divided by 4. 4 4s are 16, remainder 2. and then 26, 4 6 are 24, remainder 2, 29, 4 7s are 28, remainder 1. So why do we write as multiple of 4? Because I power 4 is 1, that is what we know, and the remainder is 1, it's explained here. So 1869 is minus 1868 minus 1, and that is expressed as 4 into minus 467 minus 1. So the remainder is 1. That is what is here in minus power, therefore negative power, so it is minus 1. Okay. Now I power, this is I power 4 which is 1. So 1 power 487. And here I power 4, the whole power minus 467. The same law of indices here. A power m into n is equal to a power m, the whole power n. Is it clear? Your m is 4, your n is minus 467. So a power m into n is equal to a power m, the whole power n. Into, of course, I power minus 1. So base are same, powers will be added. So that's what you have here. So I power 4 is 1. So 1 power minus 467 into I power minus 1. And this is 1 power anything is 1 minus. Now I power 4 is 1. So 1 power anything will be 1. Next step, 1 power anything is 1. So 1 minus 1 into I power minus 1. And you know the value of I power minus 1. The negative powers of I. We have learned I power minus 1 is minus I. So in the place of I power minus 1, we substitute minus I. So 1 minus of minus becomes plus, and it is 1 plus I. Therefore the value of I power 1948 minus I power 1869 is 1 plus I. Is that okay? So next we will pass on to problem number 3. Simplify. Sigma n is equal to 1 to 12 I power n. That is a problem there given to you. Sigma, find the simplify n is equal to 1 to 12 I power n. So what do you mean by sigma? Summation. And n takes the value from 1 to 12, and you have to add I power, substitute the values of n 1 by 1 from 1 to 12. So when n takes the value 1, it will be I power 1. When I takes the value 2, it will be I power 2. When I takes the value 3, it will be I power 3. I takes the value 4, I power 4. You must go up to what? 12. So plus sigma is plus summation. So it is I power 1 plus I power 2. Then n takes the value 3, I power 3. Then n takes the value 4, I power 4. N takes the value 5, I power 5, etc. I power 6, I power 7, I power 8. I power 9, I power 10, I power 11, I power 12, all to be added. That is what we have to find. We have to find the value of this big summation. But we know certain values. I power 1, I power 2, I power 3, I power 4, all you know. So we will substitute that directly. First, I power 1 is I. Then I square minus 1. I cube, you know it is minus I. So it is minus I. Then I power 4, 1. So I am substituting the first 4 terms. Okay. Then for higher powers, you know, it should be expressed as I power a multiple of 4 into the remainder. So now I power 5 can be written as what? I power 4 into I power 1. So ways are same, powers will be added. 4 plus 1 will be 5. I power 6, how can we write? I power 4 into I power 2. Because again base are same, powers will be added. A power m into a power n is a power m plus n. So 4 plus 2 will become 6. Similarly 4 plus 3, I power 7 is I power 4 into I power 3. I power 8 is I power 4 into I power 4. Or directly also you can say I power 8 is 1. Because I power 4 the whole square, you can say like that also. I power 4 the whole square, I power 8 as, and 1 square is 1, directly also you can say. Anyhow, I am making all these things I power 4, so I am uniformly doing that also as I power 4. Then I power 9. So I power 9 can be written as what now? Again, higher power of multiple of 4 can be here I power 8. There I can go only up to I power 4. That's here I power 9 I can write as I power 8 into I power 1. Then I power 10. I power 8 into I power 2. So ways are same, 8 plus 2, 10. Similarly, I power 11 can be written as I power 8 into I power 3. This is I power 11. Then I power 12 will be as it is, because I power 12 is a multiple of 4. 12 is a multiple of 4, and directly you can write I power 12 as any multiple of 4. I power any multiple of 4 is 1. I power 4n is equal to 1. So directly we are writing that. Okay. So these 4 terms we have already simplified. Now I power 5 is I power 4 into I. All these we have split according to the product as I power 4 into I power the remainder. Now what happens in the first 4 terms? Plus I minus I gets cancelled. Minus 1 plus 1 gets cancelled. So the first 4 terms become 0. Yes, these 4. I minus 1 and plus 1. All those 4 terms become getting cancelled with I and minus 1 and 1, it becomes 0. Then this is I power 4 is 1. So 1 into I. Again I power 4 is 1. 1 into I square. I power 4 is 1. 1 into I cube. I power 4 is 1 into 1. I power 4 is also 1. Then I power 8 is a multiple of, I power 8 is a multiple of 4, like I power 4n. So that becomes 1 into I. I power 8, again 1 into I square value is minus 1. You know I square is minus 1. Then I power 8 into I cube is what? I cube is minus I. I think you can make this as minus I. 1 into minus I. I cube is minus I. And I power 12 is 1. Is it okay? Here it is I power 8 into I cube. And I cube you know is minus I. Okay. So now this is 0. Now 1 into I is I. And 1 into I square is minus 1. 1 into I cube is minus I. And 1 into 1 is 1. Plus 1 into I again, for these 4 terms, 1 into I is I, 1 into minus 1 is minus 1, 1 into minus I is minus I, and then plus 1. So what happens again? I, minus 1 plus 1 gets cancelled, that will become 0. I, minus 1 plus 1 will become 0. So this is also 0 and this is also 0, so the total is 0. Therefore, sigma n is equal to 1 to 12 I power n is equal to 0. Is it okay? Yes, we will go to the 4th one, a very simple problem. I power 59 into 1 by I power 59. This is also again a negative power if you take it to the numerator, or you can simplify whatever way possible. Let us try. So I power 59. How can you write 59 as a multiple of 4? 56 plus 3. Because I power 56, you know 56 is 14 fours are 56. 4 into 14. So it's a multiple of 4. So I power 56 will be 1. So I power 59 can be I power 56 into I cube. The remainder is 3. When you divide 59 by 4, it is 14 times 56 and remainder is 3. Plus 1 by I power 59, again same thing, I power 56 into I cube. So I power 56 is 1 into I cube. Plus 1 by I power 56 is 1 into I cube. So it is 1 into I cube. 1 by 1 into I cube is I cube. So I cube can be taken to the numerator as I power minus 3, and you know the value of I power minus 3 as I. So I power 3 is minus I. Remember the difference. I power 3 is minus I, whereas I power minus 3 is I. So be very careful. So now this is minus I and plus I gets cancelled, so 0. So the value or simplification of I power 59 plus 1 by I power 59 is 0. Is it okay?